The opportunity to be here and to share some thoughts on this. I'm gonna, from Pernelli's talk, I'm really gonna scale things down considerably. For those of you, and most of you who don't know me, I'm an experimental psychologist, and I do laboratory work on problem solving. Sometimes I call it creative cognition. I like to think that I also look at creativity. And I thought I'd start the presentation by saying something a little controversial, to the effect that the possible is not possible. So there we go. And that possible is illusory. And in fact, it's the illusion of an actor or an agent, or even in semiotic terms, an actant, that moves by forgetting the cost of transportation. This is taken from the second half, or the last third, I should say, of Bruno Latour's Pasteurization of France, and where that last third is just a book full of these cryptic aphorisms about all manner of things. But I love that quote, and I think that quote needs to be interpreted in terms of not that there's no ideas, or not that you can't imagine things, or that imagination is not important, but as soon as you transport the idea outside, so transportation, of course, can mean expressing the idea to an interlocutor, of course. It could be on a small scale. It could be on a much larger scale, of course, in the scale of work that Pernelli described earlier. It could be constructing a maquette of something that you want to sculpt. It could be preliminary sketches. At any rate, you need to articulate that idea. That idea makes contact with the world. And when it makes contact with the world, what it's changed. You know, the old saying that no plan survives contact with reality. Well, I guess in some sense, no idea survives contact with reality. That doesn't quite work, mind you, because it's a little too dualistic. In fact, I think that I quite like the opposite. You know, reality doesn't survive contact with ideas. But I think it's a bit of both. Anyhow, I'd like to unpack these ideas, especially as they relate to problem solving and creative cognition, especially as we study in the lab, and illustrate how I use some of those ideas to try to make sense of how the possible is realized. So I'm interested in cost, not so much in cost, because the kind of work we do in fact is not very costly, not in terms of research funded, but in terms of effort and energy that our participants bring to bear on any given task. But I'd like to show you some example. I'll start with a simple example, and I'll move on to an experimental demonstration in a laboratory, where we look at what happens to an idea when it is materialized, when it is translated, when it is transported across media. So we look in terms of the currency as well as the results of those transactions. And I'm really interested in the objects that are constructed along the way. This object thought mutuality in the title really is about, or the idea that there's a wonderful transactionality between the object that are constructed and the actant that constructs them. And anyhow, so here's my first example. So I sound like a huge Francophile, and I'm kind of not, but anyhow, that's another story. The French called puzzles casse-tête, very poorly translated as, I guess, head breaker or head cracker. Of course, being Anglophiles themselves, they sometimes say puzzles. Here's one that I came across in a pre-pandemic life, crossing the channel, and a ferry crossing to France a few summers ago. And this was this freebie puzzle that came with my daughter's free happy nugget meals. It wasn't free, but it was happy anyhow. Now it's a very strange puzzle. It's not a very complicated puzzle, of course, because all the shapes are regular. The nasty thing about this, and perhaps because it was a French boat and all the kids are very Cartesian, but the pieces were not detachable. So essentially she gave up real quick. So did I. It's hard in part because, of course, you can't manipulate the world, right? And so the transportation cost here, if you have to transport anything, it's all mental. So you have to visually simulate those transportation. The currency of those transactions all mental as well. Like it's working memory currency. So you gotta, from the left-hand side, you know, the selection window, you gotta select an image, then transport it on the right-hand side, the answer grid. And so you gotta use very muscular visual imagery to augment this invisible image. And so on the other hand, when you look at the selection window on the left-hand side, then you've got to sort of inhibit or dampen all the stimuli that come at you, because you've got to ignore those that you've already selected. And anyhow, so it's not much fun at all. So the possible in this instance, of course, is a solution to the problem, and how you get to the solution to the problem. I thought, you know, we need a bit more material engagement here. And so we promptly took scissors to this thing, and we created a very simple puzzle, 12 pieces. Again, all the shapes are the same, so it's quite easy to do. But there's something wonderful and transformative about doing this task this way. I'm going to do it just to showcase my puzzle solving skills to you. Now, of course, the task is very, very different that way, isn't it? And what's interesting about it is that the possible, I'll stop saying that word, although it's not inappropriate here, is realized, right, is reified over time gradually. And in the construction of that object that will end up being the normative configuration that that corresponds to the image in the puzzle. What's happening as well as the object evolves. So, you know, I'm interested in how it's created over time. I could trace its evolution. You realize as well that the environment in which the puzzle is situated becomes much more cognitively congenial. And by that I mean is that the selection process, the decision-making that that's involved here in selecting the pieces gets easier and easier, because the object gets smarter and smarter. So you're smarter in solving this puzzle, because the object that you're creating is also very smart. It's getting smarter by the time. It's sort of a snowballing process of intelligence and creativity that's embodied in that object. And so we can complete the puzzle this way. So really the point I want to make in this instance is, well, of course, there's no science of puzzle solving, or maybe there is, and we could get a big European grant to look at this. What's interesting for me is to look at the evolution then of this object. So in the transportation here, the transactions, of course, are not very costly. What I'm more interested in, though, is nonetheless, you're making contact with the world by, you know, slowly articulating your vision of what the image might be, what the solution of the puzzle might be. And that articulation is embodied in the object that, as I said, that sort of snowballs into an interesting one with lots of creative properties. And so together with the object, you're cleverer, you're faster, and you're a better puzzle solver, as it was. As I mentioned earlier, we do work, I say we because this work was done in collaboration with Wendy. So designed with her, we ran these experiments together. This is a very simple puzzle. It's a psychologist, humor me there for a minute, think these puzzles are very interesting. They're part of a class of problems called insight problems. They're insight problems because they're designed in such a manner that they're difficult to solve, even though they're very simple. They're stumpers, if you will. This is called the triangle, a coin puzzle. There are 10 coins here. I've actually labeled them. There's different versions of this task, of course, but there's 10 coins that are configured in a triangular shape that points down. And the solution, or participants are asked to turn the shape into a triangle that points up. Oh, well, that's easy. Anybody can do that. However, there's a really nasty constraint to this problem, is that you can only change the shape of the triangle from pointing down to pointing up by moving 3 coins. So 3 coin is a big constraint, and it's very difficult. By that I mean is very few participants actually can solve the puzzle instantly or solve the puzzle under 1 minute. So participants can move the coins, and what they tend to do early on is they start moving. We've already moved 3 here, 4, 5, and 6. They go, oh yeah, okay, I've changed it. But of course they moved 6 coins. Of course that violates the constraint. So here, what's the possible here? Well, the possible something looks something like that. However, it's difficult to make it happen to realize that possible because of that nasty obstacle. So the way you think about the problems, that's got to be restructured, as they say. You've got to overcome an initial tendency to move the coins willy-nilly to form this triangle that points up. So participants find it quite hard. We were very interested in determining how they solve this problem, as well as tracing objects. And objects here, in fact, are models of the solution. What's a model of the solution? Well, they're the configurations that dynamically change over time as participants work on this puzzle. So we've got this rocket science observation lab at Kingston with overhead cameras. We program the task on a electronic tablet, and participants then touch the screen and move the coins. We've also instrumentalized the procedures. So we place the problem on a grid with numbered rows and labeled columns. The coins themselves were also labeled. So on the basis of video data, then we could recreate with a fair bit of granularity exactly how the shape evolved as participants labored a solution. I know you don't see this very well. That's okay. I'm going to blow it up in a second. Here's a case study. So we ran this task for with over nearly 100 participants. Here's one of them. So we did these detailed video analysis for all the participants. This is a schematic representation of the puzzle as it evolves over the last, in this instance, the last 15 moves, so 15 trials. Let me blow one section here. So this is moves 47, 48, 49, 50. How do you solve this problem? Well, you solve the problem by moving the corner coins, the vertices. And I've actually color-coded them here. So QRW are the vertices. I've also color-coded for you in this weird limey green, the correct position of the corner coins that will result in the solution of the problem. So here's someone that's moving the coin. So on trial 47, for example, well, I don't know what 46 was, so let's say 48. It's Q, it's coin Q that's moved a tiny bit to the right, yeah? And 49, W's move a tiny bit. No, it's moved up, actually. Participants always have the opportunity to reset the board, so it resets to the original configuration. So this is what they did on trial 50. This is 51. So what I'm showing you here is an object, in this instance, as I said, a model of the solution that's very slowly shaped and reshaped with tiny movements, obviously. Well, not obviously, but in this instance, these movements are quite micro movements. And the participants eventually, so for example, in frame 54 here, the participants is very close to the solution. But at no point did our participants, in fact, none of our participants at one point stopped and said, oh, I know the solution. You've got to move Q, R, and W in these areas. All our participants constructed the solution before announcing it. And sometimes, and we have lovely video evidence of that, they construct the solution and they go, it's as if the solution could only be perceived once it was constructed. Okay. So who solved this problem in this particular case study? Indeed, all our participants. We would argue it's a system that solved the problem. It's the coupling of the agent or the actant with the tablet. And together, they were able then to construct, to reify the normative solution to this problem. When was it solved? Well, the evidence we have is that it's solved when it was completed. And by that I mean is really the movements, the micro decision, the microgenesis of each movement is largely myopic. It's only when the configuration kind of matches the normative's answer do participants realize that they've discovered something. And I think that's quite interesting. How was it solved? Well, with a great deal of difficulty. It was solved gradually, although not linearly. Some moves configure the object in interesting ways, other moves don't. Eventually, some moves offer more traction, and in a very very small way, eventually the coins are adjusted to create a normative solution. So I think our efforts to answer the how question should hamstring the reflex to endow creativity in the mind. Here, the creativity is a very distributed and shared a process that is nicely embodied in the object that's constructed over time. I'm going to end by going back to the cryptic aphorism, talk of possibilities is the illusion of actors that move while forgetting the cost of transport. Yeah, the possible here really is actualized and reified by by translating ideas into the world. So ideas rub against the world. The world is changed as a function of the effort to articulate these ideas, as is the actant. So there's a lovely transactionality to the process. So let me close by saying a few more things. Creating the possible. Following Latour, I would say the possible is not quite in the absence of transportation. So that alerts us to the importance of mapping out how these things are articulated materially, physically. Either, of course, in this non-dyadic, it's not quite a dialogical situation, although presumably there's some kind of dialogue with the object here. We got to be careful when we think about transportation. It's not just implementing an idea into the world. The very process of implementing the idea, of articulating the idea, then also changes both the world and the idea. And I think the most interesting perspective, to wax a little philosophical here, is that issues of epistemology and ontology, that is what the world is and how you know the world, are really tightly intertwined. This is a verbatim discussion with my daughter. So how are you going to build this? I ask her. I swear she actually said first, Papa, I have no idea. I have no answer to this question. That's right. But then I'm sure she said the following: sometimes I see as I go along. And indeed she does. Thank you.